Hello, hello, everybody. Are we live? Did I make it? Oh, I think I made it. I can hear myself. Wonderful. Fantastic. Let's have a good day today. Let's just chill. Yep, there's my phone. Twitch getting me. Let me open up Twitch chat. You guys could already see it. Join the Discord. There's links down below. And, you can get announcements every time I go live. Catch these streams when they happen. King Bun says, "Ooh, baby. Ooh, baby." But yeah, there's a ton of stuff that happens in the Discord. Be sure to check it out. Links down below. And announcements every time I go live. Get help with code. Post something that you're interested in, etc. Oh, we got a bunch of fancy emotes by King Buns. Oh, can I do these properly? Here. Oh, nope. Here, hold on. Where'd it go? It disappeared as I brought it over. This OBS client is so buggy. Hey, there they are. Beautiful stuff. Alrighty, I don't need to be playing my own stream anymore. How's it going, King Buns? Thank you so much for tuning in. Okay. Today, as you can see by the title, we're working on LensorOS. We're doing something a little bit different. I've done it before, but I haven't worked on it a ton, so it'll be fun to try some things out. Oh boy, that was slow. Okay. Let's just get into the directory to begin with. It didn't exist. What? What just happened? Am I crazy? It's just, okay. Dured isn't working. I don't know if Emacs is freaking out or what. Is it the // That would be it. Okay, weird. So the // is tolerated by the autocomplete, but not by the actual function. Let's do this. Kingbun says it's going. Had to make a Zendesk response bot on Azure Functions today, and it was simply awful to work with. That sounds horrible. I'm so sorry. My condolences. Anything Azure is something I don't want to work with. Jave Smear says, good evening. Good evening, Jave Smear. It's so good to see you. Thank you for tuning in. Okay, we made it to the directory. That was rough. How's it going, Jave Smear? How was your evening? How was your day so far? It's evening as well for me. Mid-afternoon, I'd say. We're just going to work on the OS and chill a little bit today. I recently revamped how everything works. Yeah. I recently revamped how everything works. As far as the build system, so there's now a top-level CMake tracked in Git. And this now has a ton of targets to cover everything from the kernel, user space, libc is all part of that. And then we have the tool chain, we have bootloader. Everything here is so much. And then we have a bunch of boot media generation targets, which moved from the kernel CMake, and QEMU run targets. So if you have QEMU installed and you can generate boot media, then you can automatically do all of that and boot right into LensorOS. Do note, it's a complicated build, and I recommend following the instructions, and also the instructions aren't necessarily perfect because I wrote them. So putting that out there. The Markdown Emacs mode is so buggy, and not buggy, but like unoptimized in newer versions of Emacs. I don't know what they changed. They must have made a timer default faster. Jave Smear says, all day is evening. Evenings are awesome. Nice. That's good. But yeah, you just have to build the bootloader. This needs to be done on a Unix-like system for now, for this bootloader. The Ratty bootloader, which we're working on migrating to as it becomes more featureful as well, which is it's a bootloader I made for UEFI. But for GNU EFI, you do need a Unix system and make and a C compiler, and you should be good. The code's from like 1990 and very compatible, so this shouldn't fail. If it does, it's going to be troublesome. It's probably just part of the makefile I broke or something. But they work. I've tested these. I've made the bootloader. And there are, like I said, targets to do this now. If you're on Unix, then you can actually make the bootloader automatically. And you can use CMake. And as you can see, that's not part of here, because I haven't updated all the documentation yet, because I just made the top level CMake like yesterday. But yeah, there are a few dependencies. It's not too bad. Really, the ones you got to worry about are right here. So you're going to need create GPT, which is something I made, but there's pre-built, these are out of date now. I have to release new pre-built binaries. But you're going to have to build create GPT. It's really easy, simple C, cross-platform, just uses simple libc functions. So there's nothing hard to compile there. It'll take 5 seconds, I promise. And it's all CMake, so. King Bun says all of that was yesterday. I didn't do all of this yesterday. I did make the top level CMake yesterday. All of this has been around for a long time, because this is just how we generate boot media in different ways. El Torito, CD-ROMs, or VDIs, which are basically just GPTs, but in a different format, which is more compressed and used by VirtualBox and Windows. Whereas image raw is just like the raw bytes of FAT32 images. And you do need DD and mtools for this. Luckily, DD is common to have on many like Cygwin and MSys or MinGW or all of these, or WSL even. All of these have DD, so we use that. We could also use truncate. I've been thinking about using truncate instead, but that's harder to find on Windows. But I might just make it dynamic where it uses either. And then you need GNU mtools, which I have pre-built binaries for Windows, or you can just install it if you're on Debian or Unix or whatever. It's really not too bad. It seems like a lot, but it's not too bad. As for an entire OS build system. And of course, you're going to need CMake. Anyways, once you do that, then the kernel is really just as easy as building it. You do need to build GCC. Again, you're going to need Unix for this, which is the other targets here, the tool chain and the Canadian cross compiler, which is built on Linux to run on Windows to generate programs for LensorOS. It's beautiful. And it works. I use it every day. I'm on Windows. It's amazing. GCC is very cool in how many platforms it can target and support, and it's very awesome. But yeah, so we have a custom patch of GCC that we use to build everything. That way it knows, for example, just to take a look-see, it knows that the page size should be 4 kilobytes. It should link with libc by default. Unless, of course, like no standard lib is performed. It should have these included before anything else, and it should have these included after everything else. These are more libc stuff. And this is a sysroot stuff or paths to look, and then it's also preprocessor definitions, so that in code you can say ifdef lensor or LensorOS, right? Anyways, stuff like that. And then there's also stuff like I added my little patch to auto-dereference struct and record pointers to get their members. So in like C, when you normally have to do AB, you can now just do A.B, but I'm still working on that patch because it's not perfect. It lets some cases through where it shouldn't. Anyway, what say you we actually run this thing? Oh yeah, I got a new version of new shell as well. So we'll see how this performs. And we're in Streama 2022 LensorOS. And then we can just do a build. I have a Winja build directory, which is Ninja on Windows. Saraid says, yep, what's up, Saraid? How's it going? We got King Buns, we got Saraid, we got Javesmear. The crew's all here. Okay, we can clean the entire OS, make sure everything rebuilds, and let's just do this. By default, it should build image GPT, which is a GUID partition table partitioned disk image, and it'll just build that with the LensorOS bootloader and kernel and another partition, which is the LensorOS data partition, as you can see. How beautiful. Looks like it worked. And then we get our final disk at this place. Coolio. TNT Master says, oh, we're doing OS dev today. King Bun says, where we dropping? What's the one in the middle of the map? Polchinky? Polchinky? I don't remember what it's called. We're dropping Polchinky. Everyone always marks that. For no reason. They're like, well, I don't know where to go. Or school. There's another one. Everyone drops at the school. Why? How's it going, TNT Master? Where's the guy that you always talk to today? He's in the chat. I just didn't warn him. I didn't give him a chance. Don't blame him. It's me. I just started streaming because, you know, I'm having a good day and I'm chilling. I'm ready to stream. Sorry, with the giant eyeballs. I forgot I didn't fix that. Yes. It's beautiful. Anyways, if you have QEMU installed in emulator, look at that. That's probably going to sound horrible. But look what we got. I can't zoom it in because such is life. And but on YouTube you can zoom in now. So try out that new feature. How about you? Try that on Twitch. Sorry, don't know what to tell you. Anyway, we're greeted with a suspicious-looking, familiar color. You'll notice this color is a little familiar. James Smear says, nice boot jingle. Thanks, yeah. It's always good to know that things are working. And that's running when multi-processing is already set up. So interrupts are enabled and we're switching between user space and kernel space while the sounds are playing. Because kernel has to talk to the pit to play the sounds, because we don't have a real sound driver right now. So it says, oh yes, just like I always make all my backgrounds one-y. See, I can't deal with a fully neutral gray. It drives me crazy for some reason. What was I doing? Oh yeah, this is the OS. You can type things and delete things. And if we type, for example, pwd, you can see we're in fs0, right? We're in /fs0. That's our current directory. I haven't written like ls yet because I don't have the syscalls for directory iteration done. So you will notice that we could do a blaze it. A blaze it map. And it returns, what does it return? What's that code? Oh, it's 420, that's right. So we have a little shell. LensorOS has a little shell. And let's look at the code for this, because I just want to give people context for when I dive into the deep internals. This is the program we're running. It's just a C program. It's not really that insane. We have a buffer for command and a buffer for command output. And basically all the standard out gets from the child processes, gets redirected and written into this buffer. And then we just draw that buffer to the screen. And we also draw that buffer, or write that buffer to the terminal out, UART. And you can also type in through UART, and it interacts in both places. So you can type in through the terminal to control it as well. You have to press Control-Enter. I don't know why. Hopefully that makes sense. So you can see that these are actually the same echoing the same things. They're basically two terminals connected to the same shell, if you want to think about it like that. Anywho, That's LensorOS. It runs and it works. You can see we're running programs, they're exiting, we're getting the exit code. And for the most part, it's not crazy. You can see what happened here is just it doesn't redraw perfectly. So it's this line here is uncleared. We're lining up with 48. But you can see we did get 420 as an exit code. TNT Master 58, why is your YouTube channel so small? You deserve more subscribers. Thank you. I can't believe I have the amount that I do. I'm almost at 1,000. It's insane. That just boggles my mind. 1,000 people. I still can't believe I have over 1,000 views on some videos. Like, what? I can't even imagine 1,000 people in a room. Other than like when I've seen it in real life, obviously. I can remember 1,000 people in a room. TNT Master, I have a suggestion to get more subscribers. Uh-oh. Should I get in a hot tub? Would that help? So this is the C program running. There's some definitions so that we handle things properly. Don't worry about it. As always, you have preprocessor definitions to handle the inputs of the event system or whatever. However it's set up. But you're seeing we're just drawing a prompt, which has a frame buffer that we modify by drawing a PSF1 font, which we've loaded from the file system. Right, we load default font, and then we basically have a glyph buffer for ASCII characters, and we can print from there, and that's what we do. Pretty cool. Hot Tub OS Dev would be well received, I think. RxRe says 1,000 people in a room. Well, your average high school is like 2K. How many halls and sports areas could they shove students in? Like 4? Lamau. With some still in classes. There was a lot of people at school. You should do devlogs. What is that? What do I do that isn't a devlog? Because I'm good at like with the compiler, I do basically devlogs. Are you saying like shorter edited videos? Like not just stream posting the VODs? That is probably something that would work. But yeah, as you can see, we have our entire own libc that we're working with. You can see like I've written, and mostly Saraid has written this file. But we've written so much stuff, and it's really a mess. I love it. Because it all works. We're running programs, we have things going, things are happening. Maybe do a summary of what you do in a month. I don't know if I can, because I don't remember. Saraid says, edit your streams down to 20 minutes and you've got yourself a devlog or something. That's what I was thinking. TNT Master says, write it down. I have like 4 notebooks that are all used for different things, and I constantly have to replace them because I get to the end and I go, oh, I'm out of paper. I write too much down already. I gotta write less down. But you're right, I should keep track of it somehow. Even if it's just like in a changelog file or something. But yeah, it's very basic. It's just something I've written to get up and running. It's not the end goal for the shell of LensorOS. This is just literally get it working because it looks cool, right? It's nothing too complicated. But yeah, you can see we are searching the file system. Once we get a command, then we say, if it's not a built-in that we've recognized, like quit or poke, then we can just test the file system 0, which currently is just the, data partition. And /EFI is the boot partition, based on the GUIDs. And of course, none of this works if you don't boot with a GPT disk. If you boot from an El Torito, then all you're going to get is the boot smiley face that you see right when LensorOS opens. Because, it's not going to be able to load the user space process from FS0 and run it, so it'll just fail. which means it'll just play the sound and hang forever, as far as I know. Yeah, my syntax highlighting is, it just says, my ClangD just kind of gives up with everything. Syntax highlighting is, it's like, you know, it's a function. These are things in a function. It does really well as far as error handling, because it doesn't know what sysrepfd is, which is fair because it's in sys, libc syscalls. And for some reason, ClangD will just not listen to this file. It's really hard coded. I mean, I can't really blame it. Just look at syscall. Oh yeah, you want to actually see the monstrosity? Dun dun. It's horrible. Do you see this? This is the C interface. Naturally. So, you know, you just call syscall. And it's simply that. Probably because it doesn't know that Lensor is actually defined. Maybe. I'm kind of curious now. It should update. Do I need to do it here? I'm just curious. Okay, as far as I know, it's not that. Because it should be able to tell what's defined with the sysroot and everything. No, there wouldn't work. Why there wouldn't work? Do I put up here wouldn't work? Before we include syscalls? I don't think it's that. I think ClangD just isn't having it. I don't know what it is. It does the same thing with standard out file though, which you think it would be like, isn't that just a macro? What are you on about? Either way, defining that manually isn't a good idea. Definitely not. I was just seeing if it would fix it. I think it's just has to do with ClangD being written for Windows. Make an IDE. I mean, I'm working on it. There's Light. I'm working on a text editor, and it has tree sitter syntax highlighting. You can extend it with your own Lisp functions, so you could write any IDE extensions that you might want. D&D Mouse just says, oh, didn't see that. You haven't seen Light? It's on my Codeberg. You should check it out. It's also on my GitHub mirrored there, but I'd prefer if you checked it out on Codeberg, yeah. Here, I'm just going to do this. But yeah, it's a text editor. There's now 2 backends. You can either use SDL2, it's a little simpler, or you can use OpenGL, which is simpler to build, takes way longer because it builds all its dependencies and has like 4 sub. It's bad. Is your profile pic on Codeberg Soding Daily? Yeah, it's the Pog. It's the Soding Pog emote. He put him up on that, he made the emote generator, and I just used that to make a bunch of emotes. Where are we at? LensorOS, we're looking at things. This is what it does. So you see we have pipes, so we can open a pipe, which has a read end and a write end, and you get 2 file descriptors, which you can then use the unistd, right? Close, read, write, blah, 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 open, close, read, write, which is basically, you know, just using file descriptors instead of file pointer opaque objects. So instead of file pointers, it's just int fd. And because that's what we get here. RX Reese, you didn't answer my question. What was your question? Why did you need that macro hell for syscall? I see. I didn't see your question. Sorry about that. Your syscalls, macro hell. Basically, syscalls have anywhere from 0 to 6 arguments, right? And sometimes these arguments have to be put, it depends on the LensorOS ABI, right? But right now it just follows sys5 pretty closely, which means that the first few can just be matching with regular arguments, but then after a few it's actually different because I need R11 to store the stack pointer. Anyways, it's complicated. Basically, there's a bunch of complicated handling that's needed with ASM volatile, and then we have to actually make the syscall. That's all a mess. Wouldn't it be faster and easier to define 2 generics with 4 and 6 args depending on the ABI? What? 4 and 6? I don't know. Maybe. I'm not sure what you mean. But basically we can define it pretty regularly up until here. Then it requires some nonsense. And this is just the implementation, because we have to prepare all of these, and then we have to do it. Suraid wrote this, you can also ask him. Suraid says, Unistida CPP still uses extern C, should be begin decals or whatever it is. Definitely should be that. It probably was before we made bits decals. You may as well abstract fast call as C args and then go for annoying stack pushes. Store whatever trash in the first few. It's not like a few extra moves would matter. I still don't exactly understand what you're talking about. Or how it's different from what we're doing. We're just moving things into registers. That's it. And then in the C API, you know what I mean? You have to use a generic macro with var args. And then in the C++ API, we can use a much simpler variation. Anyways, this is all just the preamble. As you saw, it works, it runs, and let's go into an issue, which is if we run it. Yeah, the C++ version is just a template. It's like 80% shorter or something. Exactly. Hey. But yeah, so let's just keep running. Blaze it. Let's run pwd. Let's make a few things happen. Blaze it. Poke the kernel. Blaze it. Blaze it. Pwd. Blaze it. You know what? We'll run pwd again. Hey, look. Something crazy happened. Did you make the boot jingle yourself? Yeah. I think Justin Timberlake originally sung it, and I was inspired by that to make this little jingle made in code. I did code it myself. I didn't make the song. I'm saying you could do the same with the first few args that don't depend on manipulating a stack. I'm not worried about it. There's no speed worry right now. There's no performance issues. Everything is very fast. Things can run thousands of times per second. Not a problem. Let me know if you can get a profiler up and running, and show me where it's slow, though. TNT Master, I didn't make the song myself, but I did code it. We can go look at that just to get people looking at more code in the LensorOS code base. This is in kernel source kernel.cpp in kmain, where our pre-kernel jumps to. Because our kernel actually has a pre-kernel that has to set up a bunch of virtual paging and copy things that is passed by the bootloader, written in assembly. And then this jumps to the higher half kernel, literally just by jumping to here. Call racks. You see what I mean? But yeah, we just move kmain into there, and it's linked way up high, which is beautifully. And then we jump into kstage1, and then here's the little music code. You can see it's CD, rest E, rest A, rest G. Ba-da-da-da-da. My terrible singing. And this is the, basically this is the macro McDonald's, the first half of it. RX3 says, I know there isn't an issue with that. I see. It's totally likely I'm misunderstanding you, so don't feel bad. I'm not great at reading comprehension right now. I'm chilling. TNT Master, I missed a question. You play any instruments? I do. There's a bass and a guitar. They're like old. They're not like anything impressive, but I do have them. And I have a microphone, obviously. Since we're already looking at this, Sarade, TNT Master says you should learn the piano. I already have one. I already know how to play the piano somewhat okay. Since we're already looking at this, those should be static const expr. Bless. How long have you been playing the piano? I don't know, 3-4 years. All I have is like crappy keyboards. I don't have the space for a giant grand piano, and I don't have the money for like a big, keyboard. A Casio. So I just have like the little, I don't know what to call them. They're like 25 keys. I had a 48 key at one time, but it was old and it broke. Thank you, Sarade. I very much appreciate that. That will help a lot. But yeah, basically, and then the main thing the kernel does is it just forever says if there are page maps to free, that the scheduler has this vector of page maps, then free the page maps. That's it. And then anytime a process is destroying itself, it pushes its page map onto this vector. We probably want to make this like generic, where it's not page maps, it's just memory regions to free, physical memory regions to free, but it's fine. For now, this is all we need to free when a process, or this is all we need to free that a process can't free itself. Because trying to have a process free its own page map is a little bit of an issue. And we're going to get into that because, as you saw, we ran into a kernel panic. And we basically ran out of memory in request pages. Request pages is a physical memory allocation API. And this basically asks for a contiguous set of pages, which are 4 kilobyte memory regions. And it asks for these contiguously, so it needs them all in a row. Right? It's saying we couldn't copy a process's regions, because currently we're not copy on write. So it says just allocate more memory. That's also an option. Could the pre-kernel be written in C? No. Or is it required for it to be assembly? It's required. I mean, there used to not be a pre-kernel, but there used to not be a higher half. Because as you can see, if we take a look at some addresses, kernel addresses are very obvious. This, in fact, is a heap address, I can already tell you, because I know what a heap address looks like. It starts with 10 Fs. That's pretty much it. That's what I can tell you. A heap address starts with 10 Fs. And then there's some other tricks, like the kernel itself is mapped at 8 Fs and then an 8 or something like that. And it prints it out every time. Yeah, here we go. 1, 2, 3, 4, 1, 2, 3, 4, 8. So you can see that the kernel itself, executable, is at this crazy high address that you'll never actually be able to like address in RAM because it's petabytes or whatever up in the address space. But this is makes it clear that this is kernel addresses and stuff like that. And having this up here means that the whole kernel can be mapped in every single user space process, just not user space accessible, but it can be mapped and not get in the way of any user space actual program headers or sections or segments or whatever you want to call them. If you want to get into why the pre-kernel needs to be assembly, by the way, it's because there is some crazy nonsense where accessing the wrong memory will just break things, because everything that in the kernel is linked as if it starts at this address. Yeah, it's linked here. This is where the C code actually points to. The numbers and addresses in the final kernel executable are these numbers. They're very large addresses, right? So if you try and run a function, that function is actually linked way too high and thinks it's at a way too high of an address. So if you don't have the higher half in it, paging, right, already set up, if your higher half isn't mapped to where basically this high address isn't mapped to the lower address, then you're screwed, because just the precursor will try and like push something on the stack and it thinks the stack is at some crazy address and that doesn't exist, and then you get a general protection fault or something like that, depending on what you do, or a page fault. And then you haven't installed any page fault handlers. EFI doesn't leave you with any page fault handlers, neither does our bootloader, so your system's probably going to triple fault or just sit there. It just go, I don't know what to do. And your CPU would kind of just halt. Or it'd start doing random stuff, and it could be really bad. That still doesn't explain why you couldn't target 16-bit. I feel like Reese just likes to say things that aren't related. What does 16-bit have anything to do with what I just said? It doesn't. We don't target 16-bit because those are old, and 16 bits doesn't have enough data to store proper things or do proper math that people need to do every day. 64 bits, that's enough. King Buns, Lens, make a build target for my Tandy 1000, please. For a boot stage. What, you don't, when, okay, you don't understand the boot, the order of operations in a modern boot. To keep it strictly C. That's not a goal of mine. This is C++. This isn't even C. Welcome to the real world. And in our scheduler, you can even see that we have vectors. We have a standard library in C++ with our own extensions, thanks to Serrate. The whole C++ standard is thanks to Serrate. You don't understand, welcome to the real world. Meanwhile, you're just writing toy kernel number 234234. Okay, calm down. I'm calm. I'm laughing. I think you need to calm down, bud. I'm not saying my toy kernel is impressive and this is like, oh, I know everything. All I'm saying is that in a UEFI boot stage, right, there is no 16-bit. An x86 64 processor boots into 64-bit mode. We can go look at my UEFI bootloader I wrote and take a look. As far as I know, OXFFFF0000000 isn't normally addressable to begin with because it doesn't fit in 48 bits, and modern x86 64 CPUs only use 48 bits for addresses and not 64. Well, yeah, but it just ignores the top bits. It's kind of annoying to write 000FFFF F 0000000. You know what I mean? It's kind of annoying. It's easier to just write Fs. But you're right, those technically aren't used. And that happens in the actual page mapping itself in the kernel. but there is no 16-bit stage. The CPU is never in 64-bit mode, RX Reese. It launches into 64-bit mode, and that's where you're left at. Even in the EFI shell, it's running in 64 bits. Long mode. In the virtual memory manager, when we map things, you can see that we do all this shifting nonsense, which means that these top bits get discarded and the bottom bits get basically moved back because there's a whole bunch of funkiness with the hardware and page tables. Isn't that fun? So yeah, let's think about this. We ran out of memory in request pages. Where's request pages? It is in physical memory manager, and you can see that it just returns the physical address of a contiguous region of physical memory that is guaranteed to have the next number of pages free, while locking all of them before returning. It allocates memory, right? So the thing that we need to keep in mind is that I'm curious, is this for a YouTube series or something? I'm just streaming. I do upload the VODs. It's not for anything, it's for fun. RX Reese, you gotta be nicer, bud. You seem like you're having a bad day, okay? I don't want to time you out. We're all friends here. But come on, you can't... Whatever babble you go with. I bet you are laughing at that one. Why do you keep putting giant numbers? RX Reese, please link GitHub. Yeah, where's LensorOS, man? You can make a pull request. Let's see it. Where's your code chops? You want to see my... Look at this, bud. Remember that meme? I'm gonna get hired, baby. This thing is full up, okay? I got all of this green juice and I'm ready to let it on you, okay? I've got enough to go around. Look at it. All this green juice, baby. I've been working for so long. I got so many projects. I ain't worried about it, okay? I wonder if he left. Where are we at? Okay, we are at here. Basically, in K-Stage 1, we call init physical with the EFI memory map that we got passed from the bootloader from UEFI. And then from this map, we actually create a bit map that refers to if the bit is set, it's locked, and if the bit is cleared, then it's a free page of memory. And we have a bitmap that is based on this static region of memory, which is the initial page bitmap, right? Which happens to be 2048 bytes, which is enough to address 64 megabytes with 4 kilobyte pages, apparently. Oh, excuse me. Jave Smear says, you should commit new code to older dates to fill the whole year. Surge says, I. Why do we have an I? I mean, I could. I don't really care. You have eyes, but not I. That's true. I'm not perfect, okay? I can't think of everything. I am but one man that has built such things. Where are we at? So we basically look for the largest free memory segment in the EFI memory map. And then we say if we couldn't find a free memory segment, obviously there's problems. But if we find a free memory segment, that's great. We're going to keep that for later because now we initialize our initial page bitmap and basically lock every single page in there. And then only free the ones that have a description type of 7, which is actually a description type of EFI conventional memory, as you can see here. And there's 84 megabytes of that. This is a summed printout, so they're all split up all throughout the address space in all these different entries. Or that could probably be an enum. I wrote so many EFI loaders and APIs, and I was just done. I had it all memorized. But you're right, that could definitely be an enum. Description type of 7 isn't very descriptive. Yeah, but this will never change. It's hardware. I know what you mean. We could change that, but it's bike shedding. It's not needed. Everyone knows, like, oh, if it's equal to this type, free it, then this is usable memory. Pun intended. So it says, I think you, King Bun says, I think you just like seeing the eyes at this point. It's likely. It's likely. Anyways, we then lock the kernel in case it was lying within a free region. There is some shenanigans here where if it doesn't lie within a free region, technically we're going to have some big problems because the kernel is in a non-usable space and it's already been loaded by the bootloader. So I don't think we have to worry about that. I think the bootloader should be on top of that part, as far as I'm concerned. Anyway, we lock the kernel. Its physical memory does not and will not be freed. Anyways, we now get the page map, and then we map all of the memory, as you can see here. We start at 0, yeah? And we go up to however many pages there are in the bitmap. Or, right? However many we can address. And we basically just map one-to-one globally an identity mapping. I wonder if that should not be global. At one point, I removed everything global, and then at one point, I didn't because of all my stashes. In case you don't know, I get halfway through something and then run into walls a lot in OS Dev. So you can see I have 22 stashes. They're all named various expletives that I'm cursing at myself at the time. Total pages over 8, more magic number, shaking my head. Yeah. I'm not dealing with like somebody compiling this with a char being 16 bits. How are you planning to support the 12-bit byte mainframes from the 70s? I'm not, because this was written in 2021. No, in 2022. I don't even know at this point. What year is it? King Buns is right. My Tandy is pissed. My TX 1000. My PDP-11 won't run LensorOS. Shaking my head. Guess I'll just throw away the PEP-11. We then lock the page map itself within the page map. Ain't that fun? We then lock the kernel in this new page bitmap, because yes, this one, we've reinit it with the largest free memory segment where it can actually be placed, if that makes sense. because in order to know where this is, we need a smaller bitmap, and then it's a mess. It's a mess. Bootstrapping. Ah, yes, got to allocate memory to store the data for allocating memory. Bootstrapping go brr. Yes, exactly, Sarade. But yeah, you'll notice that a lot of this is exactly like we did just up above, because it's with the second page map instead of the first. And it's just things are slightly different. And then we just print out a bunch of stuff. So remember that printout that says physical memory initialized, blah, blah, blah? That happens here. This thing. How beautiful. All of that. So it says, Diromai, that's a lot of reinterpret casts. Yeah, I didn't understand when to use these things. This should be a static cast, but don't worry about it. It's not a big deal. I wrote that like a year ago. I didn't even know C++ at the time. I was still learning. Anyway, what we also noticed during this kernel panic, while copying processes regions. That's right here. This is in copy user space process, which is part of the scheduler, where it gets past a process that is part of that it created, basically. And it'll return a PID of a new process, which is an exact copy of the process you gave it. And it'll add this process to the queue, you know what I mean? It'll set it to running, and it'll eventually run it at some point. No problem. Just kill the process that is using all the memory. The kernel. Simple. Because that always works so well. Yeah, it does. Basically, this is how fork is implemented through copy user space process. We're running out of memory because we're trying to request pages for a memory region that is part of the memories of a process, which is all the memory regions that it is accessing right now or has access to, which includes all the program headers, it includes the stack, it includes the graphical frame buffer, it includes everything like that. That's in the memories so that we can keep track of it because the process remembers it. Javesmere, you ever touch your tongue and flex it and it doesn't feel like a part of you? No, I don't touch my tongue. I should do that. I'll have to wash my hands and try that. Basically, we just take a reference and we say, King Bun says yes. Oh no. We create a memory region that's identical to it, and then we get a new physical address, but keep the virtual address the same. And then we copy everything because we don't have copy on write. We're not that sophisticated in our page. Like, there are page faults that happen from the kernel just because of how it's written. It's not bug-free. So having a page fault not be like silently allocate more memory is not a good thing at the moment. Copy on write is not a good thing at the moment. Right now we copy on copy. Sensibly. So it says, it's not like the kernel would decide to kill, say, swap off instead of terminating clangd, which is using 100 gigabytes of memory, right? Oh, wait. That's right. OSs are dumb. Ugh. Thank you all so much for hanging out. I'm having a grand old time. Yeah, let's check this out. We copy physical address to physical address, which is a little sketch. Right? Because there might be another region that has a virtual address that is the same as this physical address, and we're not in a page map that says physical addresses are mapped one-to-one. We're in a user space page map at this point. because copy user space process is actually called from, where is it called from? I think it's called from a syscall fork. A syscall runs in kernel privilege level ring 0, but the page table, guess what, is the process's page table. Can the two overlap? What do you mean? No. Because that would mean our physical memory manager returned two overlapping memory regions when we tried to request pages. That'd be very bad. I hope that wouldn't happen. Just checking whether we need memcopy or memmove, because that's a bug sometimes. Do we have memmove in the compiler? I don't think I've have I written that? I did write that. Okay, we have memmove. It's you know, at least it doesn't use a temporary buffer. Oh god. Yeah, they shouldn't overlap because we should have new regions for each one. We can test. We can print this stuff out. Right? Let's try it. We're going to see what happens. This shouldn't happen that much because it's only going to happen when we're forking processes, which happens in run program wait PID, which is called by the shell. There it is. Yeah, they're not overlapping. We are good. But you can see that one, it's very close to being a problem, right? Because if this virtual address overlaps with this physical address, then it's going to start writing to this physical address when attempting to write to the physical address over here. Does that make sense? Because it's going to be mapped wonky. So we should really have an identity mapped page table laying around, which I think we do. Do you think we could literally just change page tables? What if we did that? In LensorOS, there's a bit of a convention where local variables and parameters and stuff like that all are in camel case. It's not something I still would do in a new project, but I try and keep things consistent as far as things are going right now. I'm really not a stickler for things like that, though. And there's places where I differ from it. But can we just save our current page map? I think we have here. Is it? It is active page map. Look at that. And then can we just maybe, I know the scheduler has the startup process, which is set to the kernel process. So could we just maybe use the page table of that process? And then after we do all this stuff with physical memory and page tables, about here, then we can, what did I just do? I'm small-brained. Flush page map. We're just going to see if this breaks things, by the way. Be careful because that early return. Is there an early return? That would be a big issue. Cached page map. What did I call it? Table. Okay, it's fine. Failed to clone current page map. Yeah, I don't even know if this is a recoverable scenario, to be honest. Because right now, cloning page maps, if we fail halfway through it, I think the only way to fail is through literally like Yeah. The only way it can fail is with request page returning null putter. So, something to think about. But yeah, we can switch back. It's not a big deal. And then say, note, must switch back to cached before returning. So this is just switching out our virtual memory mappings and the physical memory that addresses actually point to when they're accessed. So it's this camel case I. Hey. Well, things didn't break and they're now much safer. Hallelujah. I really thought things would break, but apparently that didn't break nothing. That didn't break a thing. Okay. We'll keep it. We'll keep it. Anyway, if we take a look at request pages, where we actually get this error, ran out of memory on request pages, it is because index is greater than page map length. Page map is our bitmap with all the physical addressable pages, right, in a row. And to calculate an index into the bitmap, there's a certain way to do that, and you just pass in an address and it can give you an index. Yeah? So index here is referring to I, and I is referring to first free page, and this is where the troubles lie. Request pages simply takes a number of pages and returns an address. You can't allocate nothing. One page is easy to allocate, and you can just take the shortcut of requesting one page. Other than that, we have to make sure that we actually have enough free pages to do this. Otherwise, we'll deny that request. And otherwise, if there's the number of pages requested is longer than any contiguous amount of free pages in a row, and this is actually set when we initialize things with from the EFI conventional memory map. So the maximum free pages in a row in the memory map end up as, if you try and allocate something larger than that, obviously we don't have that much contiguous memory, so it's a failure. Pretty sure all those make sense. There's a little debug message. We're not going to worry about that for now. Basically, we have this number first free page. There is an index into the page map that is supposedly free. And it should be free, otherwise this is malformed. This memory manager. So first free page should refer to a free page. Just in case it doesn't, we skip locked pages, right? In case something goes crazy. So if we are attempting to allocate something, we'll start at first free page. Skip the locked pages. Iterate I. So we'll get to a free page, right? By the way, I've overloaded the subscript operator to act as retrieving a bit from the bitmap. Okay. If the page is free, check if entire number of pages run is free. So we have a starting index, I. Sorry, it says vector of bool moment. Exactly. And then we have a run of pages. So this is some amount of pages that are in a row. Currently we have 0. Should this be 1? Because we already have 1 free page guaranteed. It doesn't matter because we just do run ++ right here. Anyway, then we do index plus plus. So this then pushes the index past first free page by 1 or whatever, right? And then we say if it's greater than or equal to length, ran out of memory. Otherwise, if run is greater than or equal to number of pages, right? So we have run. This probably could go here. Not sure. Then we can basically get our address that we're going to return, lock the pages at that address, and then return out. TNT Master 58 says, I'm going to leave now. Bye. See ya, TNT Master. Thank you so much for stopping by, tuning in, and I appreciate seeing you around. Have a good day or evening. So the issue is that when we lock pages, right? First of all, first free page is never updated by this request pages, which is something to note. Second of all, this doesn't exactly seem like it's in the right order. I feel like there's a lot of things going on here, and it's not exactly correct. So it would be good to make sure that we have all this in the right order and that there's no off by 1 errors. So let's look at request page. Basically, request page works the same way, where we just use first free page directly and iterate it until it's free, and then we return that address after locking it. Okay. Javesmear, bye-bye. But yeah, so requesting a page is quite simple. We just take an index and then try and get a free page. But you'll notice that when we free pages, first free page is never updated. And when we free a page, first free page is never updated. So ideally, if we free a page and its index is less than first free page, we could just set first free page back to index because we just set this thing to free. Does that make sense? Am I going insane? We have an index into a bit map that should point to the first bit that is not set. When we unset a bit that is lower than the recorded first bit not set, then we set the recorded first bit not set to the bit not set that we just wrote, right? I'm just going to write blaze it over and over until it crashes to show the bug. And I like to blaze it a lot, man. There it is. Sarade says, yeah, makes sense. Mr. Couture, where is your test to show this happening? Yeah, let me just write a whole testing framework for the custom OS and toolchain. Listen, trying to test a kernel is called running it. There's nothing really you can do because a kernel has full access to the hardware. You can test parts of it. Like you can say memcopy. I want a working memcopy. And you can do that anywhere. And you can write a test that makes sure memcopy works. But getting stuff like this to happen, you just do it. You know what I mean? You figure out the reproducible steps. There is no like test that you can write to make this happen. Like, oh, what if we build the entire OS, but with this user space process, and then we run it 20 times in a row, forking it, and then, oh, it crashes in this specific... Like, it's not worth it to write a test. It's easier to just record, run the OS, type blaze it 20 times in a row with enter in between each one. Observe, panic. Sorade says that's why the C and C++ standard lib are designed to also compile on Linux. That's right. Because there's nothing that they inherently depend on LensorOS for. But yeah, as you can see, we typed blazed a bunch of times and we ran out of memory. What if when we free a page, right? If index is less than first free page equals index. Is this crazy, chat? We have freed a page at an index. What you thinking about? What you thinking about? I think is this crazy? We free a page. If it's somewhere less than the first free page, set the first free page to that. Sraid says, yeah, makes sense. Okay. Just making sure, because I've done this before. I've tried to implement freeing physical memory like 8 times. I'm desperate at this point. I've already rubber ducked it to the end of the universe and back. There we go. That was it. We got a triple fault sometime after we mapped our deferred GOP frame buffer. In the middle of K-Stage 1. Sraid says, fascinating, right? You can see our physical mem layout here. So I'm just gonna, let's just see what's happening, right? Let's just print something and say phys setting index from blah to blah. Love standard print. Thank you so much. Right? Is there a race condition, perhaps? There's only one thread. There's one thing. K-Stage 1 has interrupts disabled, and it is run on a single CPU core. So K-Stage 1, during its entirety, has no race condition. What did we get? What did I just... Interesting. Seems like this is it. I don't see another one here. If we're freeing the second page, that's a problem. Why would we be freeing the second page? Why is it 32 to begin with? It's definitely 0. This is C++. We have initializers. It's just a namespace. This isn't a class. We don't instantiate this. This is just here in memory. First free page, a global variable. Sort of. It's in the namespace, but it's a global variable equivalent. And it's 0. So anytime we increase first free page, let's also record that. We're going to say first free page increase from blah to blah, right? I love that this seems so simple and it crashes everything. This is the epitome of OS dev, in case you don't know. You effectively, it's a 30-second boot time, right? You try and get this as short as possible, and you just boot up and see how badly did it break this time, because we're getting triple faults every time. And you can see we get a bunch of increases. Okay. First free page increased from 0 to 2. What that means is that we called request page. The first page was not free, but the first page, the second page at index 1 was free. We returned that address, and now the second page is the first free page. And we do this all the way through 32. And then apparently, this first one, we then free. Javesmear says, I'm going to sleep now. Bye. Enjoy OS Dev. Thank you. I appreciate that. I will. And get some good sleep, Javesmear. Be sure to get some good sleep. Right, so then it increases, so we allocate memory again. So we allocate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 right? We allocate all these pages. And this may not be an actual allocation. It may just be marking it as not valid, right? Part of a physical memory initialization. But this is probably real allocations for a page map or something, it looks like. This is probably virtual memory initialization. You can see there's a jump here, which means that there was a run of unfree pages, which we can probably confirm. I see we can't yet because we haven't printed out the physmem. Maybe we should print this out earlier. Right after init physical. But yeah, isn't that a crazy one, Saraid? This one blew my brain. It blew my mind. I was like, what is how? I change one simple little thing and just go, oh yeah, if the first free page is less than it, then update it. But yeah, it doesn't go well. So let's look at our initial physical memory map. We have one page used. So the first 4 kilobytes of memory are used. Other than that, it's free game, apparently. That's what EFI tells us. There's 159 pages there. There's 198 pages used, 1,600 free, 8 used, 3 free, 1 used, 4 free, blah, blah, blah. And this is all just from the actual EFI memory map that we get passed, right? And our kernel, of course, that we've locked as well. Does that make any sense? So we have this physical memory map, and then we allocate a whole bunch of physical pages, and we get all the way up to 159, 160, and then 359, right? And everything's fine up until then. We have a little bit of a different memory map now because we used that entire first region, so it gets merged into this first used. These are still here, and then we now have a very large memory map. So we have 6,961 pages, and we're eating right through those, apparently, when we don't free them. Let's do this. So you can see that we initialize the heap. Everything seems to go well with initializing the heap. You'll notice that this is a very common issue with the heap. This is a problem, but we'll get there in the future where we can do aligned allocations. Because taking into account the header size in a heap is like, how do you actually get an aligned piece of memory? You actually need to find a misaligned piece of memory that you can use to provide an aligned piece of memory, which is nonsense. Anyways, we're still going good after that. We set up the GOP, which means we are here, basic renderer. We get the active and deferred GOP frame buffer allocated. This is a huge physical memory allocation. So it's like 1,002 pages or something. And then we map that into memory at this custom address. Coolio? And it's just an address I chose for fun. Doesn't really matter. Then we get a triple fault. And we don't see the setup successful message. So this triple fault is within the basic renderer setup. How do you even get a triple fault here? I don't know. I do not know. So the basic renderer is being created with 2 arguments, a frame buffer and a font. That looks like this constructor. And you can see that just the frame buffer is copied, the pointer, and the font pointer is copied. You'd expect a page fault normally if it's a memory issue. Unless you're freeing the interrupt vectors or something. Yeah, I don't think we are because those are mapped up high in the higher half. As far as I know. I guess we do V2P, so it may be doing... No, that's just when we talk to the processor. It's all actually higher half. Castanis says, yo, sup? But yeah, I don't think we're freeing the interrupt vectors because that's a static thing before even physical memory management happens. And these are a part of the kernel because they're static. We could go check that out if you want. Is it here? No. Here it is. No. Where is it? I can't remember. I've done so much. I'm looking for the, not the remap pick, not scheduler switch, none of that. No, no, no. The code that actually installs the handlers. Did I write it in pick? I don't know. Oh, IDT. That's probably where I wrote it. So yeah. Here it is. The IDTR, which is part of the IDT, which is an extern IDTR GIDT. And then somewhere, yeah, here it is, the IDTR GIDT. Thank you so much, Sir. But yeah, so we have this IDT. It's part of the kernel, which means it's in the higher half every time it's accessed. And I think everything works here because we have interrupts happening. And to free this memory would mean that we're freeing at 1 megabyte, which would be, I don't even know. Wouldn't 1 megabyte be page 256? I don't think we ever do that. I think 359 is the page after the kernel. In physical memory. Because in physical memory, page 256, isn't that, am I doing that right? Oh God. Yeah, okay, so that's 1 megabyte. So this would be, by the way, I just did this. Page size times number of pages over 1024 to get kilobytes, which was 1024, which is a megabyte. So yeah, we're not doing anything like that. And we have no message of freeing a page at all. So we're actually not freeing anything. Right? Because the only time we freed something was back here when it decreased, setting index from 32 to 1. How about that? How about that? So it doesn't seem like it's the interrupts table or anything like that. It seems like something in the basic renderer is happening. We know that we see this message, deferred GOP frame buffer mapped. And you can see it's here. Beautiful stuff. right? So we're just printing two numbers as addresses. And we've basically just picked an address and said, this is a virtual address, physical target base address. So we have a target, which is a frame buffer, and this frame buffer is a base address. And then we map our virtual base address to our physical base address for the entire frame buffer size. And frame buffer size is in pages, is it not? Frame buffer size is not in pages. Does this need to be in pages? No, it needs to be less than address because we're doing t plus equals page size. And then adding that to each one. Okay. And then we map that in our current page table. We've already done virtual memory, so everything should be good. We get here, which means that we're done here. We then clear. What is clear? This might be it. Just gonna do a little printf check. Clearing, cleared. Click, 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 cleared. What did I do wrong? Print is not a member of standard, excuse me. We wrote it. I promise. It's there. Okay. Sir wrote it mainly. I looked at it and I use it. Okay, I was going to say that's interesting. I've never seen that. Okay, we get another triple fault during clearing. Look at that. Why clear? Target base address. Target base address. That's a different T. If it's not null putter, then we do it. Else we do this. What? Okay, I see. So we request pages and then check null putter. So we're trying to gracefully handle a failure here. If memory allocation fails, pretend there's two buffers, but they both point to the same spot. Whatever. And then I'm sure in swap, we basically just say, yeah, mem copy, which if they're equal, we'll do a no op. Okay. So we have some physical pages that we've requested. And then we map them. And question mark, does target ever get set? Okay, it gets set here to and target. Target is what? It's just a frame buffer kind of dangling here in the executable. Okay, static memory. That's fine. So we have this target thing that we take an address of. So this should just be an address in the kernel. That's totally fine. And then we clear and swap. So target is set. Clear fails. So we get the target base address. And then we say target pixel height. So just, I guess, start printing me out some things, because I don't know what else to do about that. Because this should not be null. If it's null, we have very large issues. Did it triple fault already and I missed it? I looked away. Clearing. Okay, that's exactly the virtual address that we've mapped it to. So as long as mapping is working, then everything should be fine. I'm just a little confused what's going wrong here. I will admit I'm quite confused because all this code seems to work or have worked. Pixel putter plus X. So this is X pixels plus Y times stride. It's kind of the generic algorithm that should work. I'm just gonna go print Y and X and figure out where we are getting to, because I'm so curious what the hell is happening. This is OS dev, by the way. It probably has nothing to do with this code that is going wrong. It has something to do with the, obviously, memory allocators. But it's something so simple. All I want to do is like look for physical memory somewhere that where you've already looked, but you know that it's going to be 0 now. So we do apparently get through a lot of the rows. Knowing that, we don't really have to know this X value. So we could just not print out this X value and see how many Y values we actually get. Does it appear to be stopping? That's a little worrying. Oh my God. That's 10,000 lines. It's going a little fast. Can I see a Y? I can't. I don't think it's ending. I mean, there should be 800 Y rows, right? I guess that'd be a lot of X's. We'll see what happens. We're getting through multiple rows. O of n squared go burr. Yeah. Definitely. That's like O of n 10 n squared. The coefficient matters when it starts to get large. Okay. There you have it, folks. We get through exactly 496 rows, 497 rows of the frame buffer. And on the 498th, index 497, we triple fault. Immediately triple fault. Which is something I guess I didn't expect. Because pixel height and pixel width are reasonable numbers, right? They're the same as render. Render is the same as passed in. Passed in is the same as boot info. Okay. So then we have frame buffer pages, which is frame buffer size over page size plus 1. How many pages should this be? So we have frame buffer size. Something is going to be plus 1. And then we have a division. Frame buffer size is just going to be multiplied 1280 and 800. Well, I screwed that one up, didn't I? So we want to add 1 to the division of 4096 because that's page size. This is going to be the multiplication of 1280 and 800. Is that 251? Am I doing that wrong? This should be... That is definitely wrong, because it's not a... Is it a square? No, it's a square. This should work. A rectangle. If the frame buffer is aligned to the page size, then FP pages ends up being 1 plus the number of pages. Yeah. And the number of pages is the size of the frame buffer. The size of the frame buffer is the buffer size. Plus 1 page. See, we add 2 pages here, so technically it's like add 2. Shouldn't that be 252? Am I crazy? I guess the buffer size can be anything. It's not necessarily this number. Anyway, pixel width and pixel height are all from the boot info from EFI, and that's not incorrect, because it matches 1280 by 800, the QEMU frame buffer. I don't see anything wrong here. We're properly using pixels per scan line and not pixel width in case those differ. So what could be happening? What if we just shouldn't be, what if we, okay. We've allocated this somewhere in memory. Where is it allocated in memory? And why is it a problem? Do we need to like just set a, this would be stupid. Do we just need to set like, don't allocate anything below a megabyte or something? That would be very dumb. So we say deferred GOP frame buffer allocated at 192 through 57B00. So it's allocated from 402. So that's above 1 megabyte anyway. Is it aligned to a line of view 32? How would we do 500 writes and then it becomes misaligned? And it's pages, so no. It's page aligned. See, oh, Just Chill, thank you so much for the follow 13 minutes ago. Hopefully you're still around. I appreciate you. We're almost at 300 on Twitch. That's incredible. Be sure to check out the links down below. There's a Discord, talk about things. Looks like we had someone, wait, what? Maybe someone deleted it? I don't know. Apparently there was something there. But yeah, check out the Discord. There's announcements every time I go live. You can get help with code you're working on or, you know, all sorts of things. It's fun. Come discuss. So we do 1,002 pages. Why is there 1,002 pages? How big is this frame buffer? 3E9000? What is 3E9000? Divide, like in, I don't know, kilobytes. Let's start with that. 4,004 kilobytes. That's like 4 megabytes. So we have like a 4 megabyte GOP frame buffer. Coolio. And then that gets mapped again in the deferred frame buffer so that we have double buffering in the kernel. We don't need this anymore. We should be able to get rid of this, but I presume it's not a problem here, so it's probably not smart to start ripping stuff out and see if that works. So yeah, we get a triple fault in here, which is not something I'm expecting, to be honest. and I'm not sure how exactly to deal with it. What if we don't clear? I don't care. Can we make it through if we just wait? This is how you know I'm desperate. I'll just try anything. Are there any interrupts you aren't handling? There are interrupts disabled for this whole process. Ah, good. That's always fun. So, I've crashed QEMU. That explains why it's triple faulting. What do you mean? Are there any interrupts you aren't handling? That explains why it's triple faulting. Maybe this explains? This might be a QEMU bug then. I very much doubt it's a QEMU bug. QEMU is very widely used by many x86 64 systems, and they can write physical memory managers just fine. It is possible that it's a QEMU bug, but the likelihood that it's a me bug are about 1,000 million times higher. So we're allocating a bunch of memory for PCI enumeration, which makes sense. It can't really call a fault handler if interrupts are disabled, I think, which is why it might be triple faulting. I see. I get what you're getting at. I get what you're putting down now. I typically prefer sticking to compilers. They're definitely simpler. So, it doesn't work. So yeah, there's no fault handler because the interrupts aren't enabled. Let's say that that's true. I'm not sure that that's true because I'm pretty sure I can... Let's just try something crazy. Was not declared in this scope. Do I have to do like that? I'm kind of just curious. There you go. It even tells you where. But yeah, I would say that that's probably not it. It can definitely call handlers even when interrupts are disabled, because we can cause a div by 0, for example. So are there any exceptions you're not handling? Probably. I mean, almost for sure, right? We have these handlers. So if it's not any of these, we won't catch it. As far as I know, a triple fault only happens if a fault occurs during the execution of fault handler. And actually, even then, that's just a double fault, I think. Yeah, but we have a double fault handler. It's definitely in there. These are from the Intel manual. And the double fault handler is purposefully simple. Maybe it needed a volatile. Maybe that was it. So it'd have to be the double fault handler faulting. Probably. You would think that it would be able to spit out to UART something. Because if we go to panic, it doesn't, the first thing it does is UART, right? Yeah, the first thing it does is pretty much, hey, print to UART that there was an error, right? And then it tries to write to the frame buffer. And I can see how this would cause a problem, right? Because we're having problems with the basic renderer and the memory surrounding it. But this standard print should go through pretty much no matter what. We're passing in frames, so it'll do this one, as far as I know. How are these different? Ah, interrupt frame and interrupt frame error. I see now. You can try adding a halt loop before the print or something. I mean, just move this up. Is that what you're saying? Is that what you're saying? I can do that. I don't think it'll do anything. I don't think the double fault handler is even being called, personally. I think it's just triple faulting. Which doesn't make sense, I agree, but I do think that's what's happening. As is evident. There we go. It doesn't work. Fantastic. I'm just glad that everyone else can see the struggles I have, where it's like, I did something so simple. All I want to do is make it where we have a physical memory manager. It works apparently already. All I want to do is make it where if index is less than free page, update that. And we do it once. We update it from 32 to 1, and it breaks everything. Isn't this amazing? It's like, it feels like a specific oust against me. What if we just say if index is greater than 256? Right? Let's just put an arbitrary limit for fun. I still think it might be overriding the IDT. How? How? I don't think that makes any sense. That would explain why the fault handler isn't being called. But we can call the div by 0 and cause that, and the fault handler is called. We can do that manually. Right? Unless somehow we're mapping in basic render, if you think maybe we're mapping here, physical target base address just happens to be what? It's request pages, right? So you're saying we're returning the kernel, but the kernel itself is located at 1 megabyte in physical memory, which is page 256, right? Which we never allocate. Page 256, we skip it. So the actual physical memory of where the kernel is loaded at 1 megabyte, which is what the bootloader loads us at, 1 megabyte. And that's what pre-kernel knows. It says we're at 1 megabyte. We need to be mapped higher. It knows it somewhere. I can't remember. It's probably through a define. So the IDT is a global thing, right? This IDTR. Unless I'm wrong, I'm trying to think about this. How does this work? So we have an IDTR, which we create in K-Stage 1, naturally, with limit set to OFFF. and offset set to IDT storage, which is a byte array. IDT storage, which we could probably... Do you know how to get the symbols from a symbol file? I don't remember. No such file. What? Oh, it didn't build. Why didn't it build? What happened? I put a single and like a dummy. That's right, I was trying the thing here, where if we just put an arbitrary limit on, don't set the first free page too low, right? But yeah, I don't know. I'm pretty sure the IDT storage is in the higher half. So we would see... It works! Hooray! Wow! It's just this stupid check. How many times can we run it, though, is what I'm curious now. Oh, it takes a sec now. Woo! All the way to a triple fault, baby. Multiple page faults in a row. Just page fault after page fault after page fault. At OX400. From kernel space, which is not good. So many page faults. Huh. 477FC0 in some page table for user space. I mean, it's not mapped, right? It should be mapped in here, shouldn't it? But why are we trying to access this address? We're trying to read this address from the kernel. Why can't we do this? What? So it's not present? So we just get some random address not present for some reason halfway. Do we even update? Are we even freeing memory? You know what I mean? Why are we just allocating like so many pages here? I don't think we ever even free memory at this point. Oh, here we do. So we're freeing memory here. Some large chunks of memory. So that would explain stuff going wrong, I guess. But yeah, if you ever see me in Discord just like complaining, going, oh my god, I hate the OS, it doesn't work, it'll never work, I've been working on it for so long and it doesn't work. This is what I've been doing for weeks, trying to get this to work. And it's so obvious and seems so simple. All I want to do is free some pages. And it works sometimes, which is the most annoying part. Hey, look, everything's working. And then we freed things, so now... Okay, it still worked. Oh, man. Oh, it's still working. Oh, boy. Magically, it's working. We ever gonna run out of memory? Look, we just keep setting the memory to the same thing. Oh! Uh-oh. It went way down. And then we triple faulted. Why are we freeing memory? That's like down here now. How'd we get to... This freed the kernel, didn't it? That would do it. Freeing the kernel would definitely be something bad. How do we free... Why? Well, it worked until it didn't, you know what I mean? We literally allocated a page from the kernel. How does this happen? We apparently called free pages on the kernel, or free page. Which just doesn't make any sense. Yeah, the only thing I can think of that could cause a triple fault is an IDT issue or a QEMU bug. So yeah, or freeing the kernel seems like a problem. How does this even happen, though? What is calling free here? Because there's no addresses here that are the kernel address. You know what I mean? 1, 0, 0, 0, 0, 0. 1 with 5 zeros. There's nothing here. Any of these physical addresses. You know what I mean? So it's a little confusing. It works a few times. Are you freeing in the wrong page table or something? What is... This is physical memory. There are no page tables. They're just addresses that we're freeing in the actual RAM. So to actually get the address of the kernel and free it, we have to like do kernel start and use the linker script thing. It doesn't make any sense. Like we literally do it lower here. We say, here's kernel start and kernel end. You'd have to do this to get the address of the kernel. I just don't get it. Unless we're like accessing an address to get an address, and the address that we're accessing to get the address to free is now mapped differently, magically, to the kernel. Well, I don't know. What if I just did like... What if we make the number bigger? Don't at me. What if we make the magic number bigger? That way we can't free the kernel. Can't you check if the address is between kernel start and kernel end and panic? And it is. Yeah, let's just do that. Yeah, we can do that. I think that needs to be and. Here. And these are going to be in virtual memory is the problem, I'm pretty sure. Are they not? Are they going to be in physical? Let me look at the link script. Kernel start equals dot, after dot equals kernel virtual. So I need to minus kernel virtual. This is a mess. Sure. I wonder if I'm just not doing that earlier. So if it's less than the end and it's greater than the start, panic. And remember, this only happened every once in a while. remember we were able to do blaze it, pwd, and then it just says, hey, you can't do that. So that's fun. Yeah, it worked great. Oh. Well, that is a QEMU bug. Why? What makes this a QEMU bug? It's not necessarily a bug. I could just be putting it in something, a state that the hardware can't get into. Which is also a QEMU bug because it shouldn't be able to do that. But it's also my fault because I shouldn't be doing that to the hardware. If we treat the hardware right, everything works, I promise. QEMU works. So kernel n, how are they used before? So we say kernel mapped. So we say, where's the first one? Mapped from blah through blah. 0 total RAM. Kernel loaded at kernel physical. Right? And then we say kernel mapped from, where is it? Kernel loaded at kernel physical. And then kernel mapped, kernel start, kernel end, which is this big. And then we do all the sections. So kernel start and kernel end are definitely our virtual. Kernel physical is the start. So what if we just did it a little simpler? And instead of like minusing kernel virtual or doing anything like that, if it's greater than kernel physical, right? That's how we do this? Yes. And then if it's less than kernel physical, converted to use size, minus, do we have kernel size? I'd have to do this. I don't care. Could probably do like static const expr if we really cared. It's just not going to work. It's not known at compile time, only at link time. Ah, that's dumb. I see. We need LTO. Oh, that's not gonna go well. Oops. So if it's less than physical plus byte count and it's greater than physical, panic. It goes. It stops. It looks fine. None of these memory regions are overlapping. Yeah. Hmm. We're not getting a panic and then just not waiting, right? I did that wrong. Right? Let's just try something crazy. Worked once. And only once. After we apparently freed some pages. We're not freeing the kernel anymore, so that's good. Well, it looks like it was a good attempt, but this stream is going to be another on the long list of stashes that don't work. If you'd like me to, I can try running it on my system to see if it's really a QEMU issue, because IRC QEMU on Windows can be a bit scuffed sometimes. Sure. I'll push this to some branch. Is it QEMU? Not a valid starting point. Ah, I didn't know I was picking a starting point. Main, is it QEMU? I'm just gonna stage it all. I'm gonna say kernel attempt to free physical pages when to reuse freed physical pages. That's really what we're trying to do. Yeah. And I'll just push that to is it QEMU on Codeberg. It is now live. I can, by the way, delete this branch. Yes. Thank you. Anyway, you can now try this code out yourself. I'm pretty sure it's not QEMU, and I'm pretty sure it's me. Because guess what? I can run Serenity OS in this QEMU that I have installed. And if it can do at least that much, then whatever we're doing should be fine, because we should be doing a lot less than that. As far as I know. They have an entire goddamn browser. I'm trying to run LS. I love that guy in here earlier just started talking shit. He's like, your number toy kernel 4 million. You ain't shit, bud. Everything you do has been done before. It's like, yeah. Okay. I didn't realize people cared. I think that those people are just very worried about themselves and that they haven't done it before. Otherwise, they'd just be like, no, that's not how you do it. I've done this before. But nobody says that. They say, no, that's not how you do it. You're being dumb. Write a 16-bit one. What? Okay, the CMake list in kernel doesn't seem to work anymore. What do you mean it doesn't seem to work? That's not the top level directory. There's now a top level CMake, remember? So it's going to be an all new build tree. Right? I just do cmake-g ninja-b winja-this. Exactly that, and it works. The top level CMake has given me an error when compiling PUID main.c. What's the error? Is it something to do with a sysroot? Did you generate a sysroot properly? Did you make the bootloader? syspwd undeclared. Goddamn sysroot, seriously. Probably. So do you have a root directory? Does it have inc? Does it have lib? Do you have a root directory? Second question, do you have a boot directory? The boot directory is made by the kernel target and the bootloader. When you make that, it's now needed. The bootloader is no longer stored in the GNU EFI subdirectory. The top level CMake should really just regenerate that, honestly. Well, I implemented it yesterday, so pull requests welcome. That definitely would be nice, though. If you can figure out how to do that nicely. You should really just add a target sysroot that runs script sysroot.shush. This is probably the way to do things. Then you can just run that or use it as a dependency if you really want on Unix. Alrighty. Well, I'm happy that it's not just me. Because I was expecting that. I've been spending weeks on this, and then I'm gonna come out, I'm gonna do it on stream, and someone's gonna go, hey, shouldn't that be a 1 and not a 0? And then it'll just work. Or something like that. Just some stupid problem or some stupid logical error that I'm making over and over because I can't see the error in my own ways. That's kind of the most difficult thing to do. I also got a triple fault. Well, that's interesting because I don't get a triple fault at the moment, I don't think. Ain't that fun? How do you prevent QEMU from restarting immediately after a triple fault? It's done by the CMake. It's one of the flags in the giant list of QEMU flags. I don't remember, to be honest. I haven't touched it. Yeah, I get this pretty consistently. QEMU bailout. As far as QEMU not exiting, let me look at the flags. This. There might be another thing. Let me look up. Let me just look up QEMU options. I haven't looked at them in forever. That's not ideal. This is bright. I'm just gonna, okay. Naturally. -D. Okay, this is a classic, wonderful search by QEMU. Jesus Christ. Where do we get? Invocation. -H, -D. Enable logging of specified items. Okay. Reset. I'm looking for you, Sir. I'm doing my best. Watchdog. I don't see reset, so It might be an x86-64 thing. So -d is actually just item. Use -d help for a list of log items. I don't know if that's going to help. x86-64 or something system. I don't remember what it's called. Okay, that works, but now it's closing the window rather than keeping it open. Yeah, I don't think there's like a wait on triple fault. A triple fault will either reset the CPU and then start from there, or it'll just stop and exit. I don't think there's an in-between, to be honest. I don't know. It sounds like it's not working on your system either. There's -no-reboot apparently. What? Oh, that's what you're talking about. Exit instead of rebooting. Okay. What about shutdown? Try no shutdown. Time to compile QEMU in debug mode and put a breakpoint in the triple fault handler. We could also step through the kernel in GDB. I don't feel like it'll help us. But yeah, no shutdown looks like it'll help you. TNT Master says, I'm back. Wonderful. How's it going, TNT Master? What brings you back? Weren't you supposed to be sleeping? Was that the other person that left? Works once. Works twice. Works 3 times. It's just random. So there's UB somewhere. How we... What's UB? TNT Master says, I'm not supposed to be sleeping. It's 7 p.m. here. All right, it was another person. They said good evening. So this is interesting. I'm going to put it in Discord. I was able to make it say good boys don't free the kernel. I don't know how, but I did make it do that. Very nice. You got frame buffer corruption. Still working on physical memory management. I would say we're doing the opposite of working. We're making it not work, apparently. So this is frame buffer corruption, where we're writing data to the frame buffer physical memory where this should not be happening. And then you're getting a general protection fault over and over and over again. It's definitely not. This is what LensorOS looked like for the first 2 months. So there's just frame buffer corruption and horrible things. This may be related to why it's crashing in clear. Yeah. It could also be having to do with this. What is it? The world may never know. So it says I. I know what you mean. It's definitely a problem. that has to do with something that has to do with this, but I don't know anything more than that. This is why it's so sad. It's like I can't change anything in the physical memory manager. It just breaks everything. So it's like, how am I relying on it being broken everywhere? It's like in the code that I've already written, it's like if I wrote it with a working physical memory manager, I'd have to write it differently. Does that make sense? It's like I have an off by one that I'm also fixing with an off by one. So then when I fix the off by one and one of the off by ones, then the other off by one actually emerges and then it goes, hey, you have all these bugs everywhere. I mean, the physical memory manager seems to be working. Does it? That's kind of the only thing we changed, and it's broken. It's just that the code that's calling into it is broken because it's trying to free kernel memory. Okay. Well, let's say it works, right? Let's say it works. By the way, so when we lock pages, we lock kernel physical. Just making sure. Okay. Kernel page count is +1, right? What if we add 1? Is it literally an off by 1 error? No, it isn't, because we're freeing the first page of the kernel, not just the last one and having things go wrong in that way. Yeah, another triple fault. Okay, that didn't help either. Wonderful. It should probably be +1 though. These are guaranteed to be page aligned, so it doesn't really matter. It can be exact. What are we doing? It's just the code that's calling it that's broken. Okay. There's not a lot of places where we free memory. So which one is broken? Right? Is it in the virtual memory manager? Is it in the scheduler when we're freeing up processes' memory regions? I mean, we can print stuff out. I don't know if it'll help. Not sure what just happened there. Emacs freaked out. I mean, I could say freeing blah pages. It really doesn't matter. You know what I mean? It's like, this doesn't help me. This is just destroy freeing pages. If it's not this code, it's some other code. Like when we're freeing page maps or when we're... I guess that's mmap. We don't really call that yet. Thank God. Still triple faults. You could do horrible things like use built-in file and built-in line as parameters to get the file in line of the caller. That way we'd know where it's being called from without having to step through it. What does that mean? To where? Where does this happen? By the way, it's definitely not here because we're freeing during K-Stage 1. So it's not in the scheduler because the scheduler isn't even working yet. This is so annoying. We free pages that have to do with a page map that we're freeing, and we free no page map. So we're not really freeing pages as far as I know about, unless it's in the actual physical memory manager itself or for the scheduler. And if the scheduler does it, let's see, it would just be here. In which case, we print out an address, but I don't even get there, so I can't really tell. Woe is me. We'll add in our stupid... Sure. Make it a big number. Let's see if that lets us get through the boot. Da-da-da-dun. Intercept is going well. I don't know if anyone's thinking about that right now other than me. Hey, look, we made it through the boot. And then... You gonna be mad at us? You're gonna be mad at us. Cool. How come? I don't know. We didn't free anything. We're just copying things and it says code should not be reached. If you declare a function with infl is equal to built-in line as a parameter, then the default value of L will be the line of the call site. Int, not inf. Oh, that makes a lot more sense. The default value of L will be the line of the call site. So you're saying add default parameters to free page or free pages? What do you, which one? I mean, that's, what are we trying to print out? I can't see what you see. I just crash and stupid stuff happens on my system. At least you get some cool looking frame buffer corruption. Look at that. That's all fancy. I just get bailouts. Because I don't know actually where you're triple faulting. So I don't know what is actually pertinent to print out for you. Just anytime we free any page, do we want to print that out? I hope I'm just stupid. I hope there's like something super obvious. I mean, right now, when I just tried running it, it got the good boys don't free the kernel error like 100 times. Yeah. So you need this printed out here. I can't do that though. It doesn't really do that for me. It just crashes. But if you're like int line is equal to built-in line apparently. And is there a thing like this? Beautiful. Okay. So a few things we can add. A little bit of that. Yeah? Unlike line and file, that captures the line file of the caller. Yeah, because those macros would just be expanded to here. I've used that before to detect deadlocks and such. Interesting. This is very cool. Ba-dum, 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 blah. File name line. I mean, I'm not going to see this, but we can pretend. I guess I could also push it for you. I'm sure you can make these changes. They're kind of... Using a debugger is, of course, preferable, but that doesn't work here, unfortunately. I mean, you can use a debugger. There's nothing stopping you. You can start up QEMU with -s, and it'll wait for a debugger. Have to go in the declaration and the declaration only. That's the stupidest part about C++. Why can't I just put those everywhere? I guess so everyone that calls the function knows what the default parameters are. Well, let's hope that we get to the triple faults and kernel panic. Ooh-wee. We're making it. Nah, we didn't make it. I didn't print out shit. Just got a bailout, not even a triple fault. We're just freeing normal memory, so... This is annoying. Well, there you go. I've done as much as I can. Do you want me to push these changes? Do you want to make them on your system? Do you think it's even worth trying? Do you think it's definitely me at this point and I should just go and cry and audit LensorOS kernel code for the next 3 weeks to figure out that one place that's wrong? Yeah, it just doesn't work. There's no... Sorry, it says, I'm not sure I would get anywhere, candidly. I meant just printing this stuff out with the line and file number. That's it. Because I don't actually get to anywhere where it crashes. It just magically crashes. But apparently for you, you get good old boys don't do bad things, which would be very good. If we could figure out this place right here. But yeah, sorry, it says, I mean, I can try. I mean, I'll just print, I can just push them. It's really not a big deal. I just want to see what the hell is printed out. Desperate times. ... Ugh. Okie doke. That should at least help a little bit. You know what's going to be really sad? It's probably just going to point to right here in free pages when we call free page. uh... But yeah, this is where I'm at in LensorOS. It's going great. This time, I just got a general protection fault. Naturally. Or like a bunch of them, rather. Well, I would go with it's not KiwiMu. We can safely delete the branch and forget all these changes in another stash, in another branch that will never be touched ever again. What's the solution? I just feel like there isn't a solution to so many problems. It's not KiwiMu on my system. Right. All I mean is that it's not working on either. It's not working because of things I'm doing. It's not working because of things KiwiMu does. TNT Master 58 just has eyes. Yeah, yeah. This is where we're at. I don't know how to solve it. And I've tried. I've done it publicly, and nobody else can figure it out. So this is kind of just how it is. I have to keep trudging along and hope that I eventually find a solution to this horrible, stupid nonsense. What if we don't free memory? Sorry to F. I mean, it's not bad. It's just, I'm at the same place I was this morning, where I've tried it a bunch of times. It didn't work any time I've tried to implement it, and nothing I do really seems to make a difference in how broken it is. And if we don't reclaim physical memory, we can keep running Blaze It until our hearts give out from partying and we run out of physical memory. But as soon as we try and update this one number, which should just work, should be fine, everything breaks. That's where we're at. It's a beautiful life, ain't it? Let's get off this dumb branch. Let's get back to something that works. Can I make a boot jingle for you using the piano? Yeah. If you give me like transcription of music, I'll do a boot jingle. Why not? I don't really care. I'm gonna delete this branch. I can restore it if you still need it, Saraid, but I'm deleting it. I don't think it's gonna be of help to anyone. Well, we're doing good. It works now. TNT Master says, when I have time, I'll send it to you on Discord. Awesome, man. I'm looking forward to it. That'll be fun. If it's just a recording, I might need like some notes or like what actual key it's in, like A minor, A major type of thing, so that I can properly identify. Because I have to actually code in the hard-coded frequencies of each note. Ah, the simplicity of it working. TNT Master says, what? Why don't you just use something like MuseScore? What? What is MuseScore? I'm not sure what that is. Is it like a program that can transcribe music in like the classical notation? Like with the fancy music note? The actual... Is there a note? I don't have it. Musical note. It's a music notation app that can also play music. I see. I've never used it or heard of it. I don't, if you send me like the classical sheet music, I'll definitely be able to transcribe it. So I just have to do it into this format, right? You also get realistic sounds. I mean, okay. Yeah. Just realistic to how it would be played. I see what you're saying. How it's notated. What if we don't free page tables? I don't know. Nothing really helps. It doesn't matter. Like for strings, woodwinds, harp keys, etc. Nice. Well, I've got nothing. I should probably eat dinner. It's late. It's not late, but it's late. I still have to cook. So yeah, if anyone wants to fix the physical memory problem in LensorOS, PR's welcome. What time is it for you? 6:14. PM. Two hours behind me. You in Kansas? You could be in like middle of Canada or Mexico as well. Or South America. Up in the middle of Canada. Very nice. Canada's a nice place. You in the States? Yeah, I'm in the States. Sadly. Have you been to Canada? Yeah. I haven't like lived there, but I've been there. Not often. I like I don't go there, but I've been there. It's very nice. I like how there's so much space. Which province? The one directly above me, I would say. I don't remember. Is that bad? The one with Vancouver in it. I don't actually know. Is that British Columbia? That's probably British Columbia. British Columbia, that's the one. I looked it up. TNT Master also says, you are correct, and it's British Columbia. Very nice, very nice. I didn't even have to look it up. I got a person right here in front of me, helping me out. How awesome. Thank you. Yeah, I've been there. In where I live, it's pretty boring. Yeah, I've also been over to like the Great Plains. It's not named that for nothing. It's just flat. There's like, as far as you can see, flat. It's really funny. Just a prairie. That's right. It's just a field. How big? You know, the size of like Texas. It's just a field. The size of Alaska. But yeah, that's LensorOS. It sort of works. There's a lot of parts to it. And we have like user space processes and multi-processing and forking and pipes and file systems and a VFS, and we have so much fun stuff in the OS. I would love for all this to come together to actually work. Sraid says, "Is that near the wasteland?" It is kinda. Arizona's the southern Great Plains. TNT Master is talking about the northern. But yeah, it's basically the same field. It's just the other side of it. When you stare out and you see nothing but a field, how sad. Yeah, I'm kind of lucky. I live by some mountains, some hills. Also means it's like windy as shit and there's a bunch of rain. So, you know, win some, you lose some. But there's also no tornadoes. So, pog. Wow, some scenery. It's true. Well, I've got nothing. I'm pretty sure that I've exhausted my mental capacity. We have too much snow here, especially blowing snow. Wet, blowing snow that just smacks your face. I know what you mean. It can be terrible. It's just like it sticks. Every single bit of snow sticks to your face. On the plus side, you can make, depending, you can make pretty good like ice snowballs that are like hard and will hurt. That's all that we need, a good smack in the face. It's true. Definitely helps, definitely helps. But yeah, I would love to know, yeah. I would love to know if anyone is spots the error. Why doesn't this work? What are we doing wrong? Should I just go over through like all what Blazeit does? There's a scheduler that an interrupt happens every like 20 times a second. We push a bunch of CPU state onto the stack, we timer tick, and then we switch process. And then it looks like we return and return, but we don't, because in scheduler switch process, right? Which is equal to scheduler switch, which is equal to switch process. Don't worry about it. All it does is copy off of the stack, the thing. Yes, very simple. And then we save floating point state in context. And then we switch process, which basically just chooses the next process, updates the CPU state, basically restores CPU state from what was saved last time from this new process. We flush its page map, and then we return. But because we have altered the CPU pointer, when we actually return from switch process and return into here, we end the interrupt, right? And we restore the CPU state from the stack, which is the pointer that we passed. So because we've modified this from the next process, we actually pop into the next process. Cool? And in returning to the next process, we then wait for the next interrupt to happen and get back to the top. With things like syscalls, it gets a little complicated because forking means that we end up with two processes that actually return to the same spot. And exec means that you end up calling this and then you never return because you do some other crazy stuff. Because we just scheduler yield after setting the process state to sleeping, because this process is either replaced and running or sleeping and should be destroyed. But yeah, so in exec, it just replaces the current process. When we're replacing the process, right, that's when we do things like unmapping the pages and freeing them. So we unmap the virtual address in the process CR3, and then we free the physical addresses. Does exit still return? I don't think exit returns anymore. That's a good question. Yeah, exit no longer returns. We've implemented that. So that's good. At least something is better. Exit now yields. Scheduler yield basically just says create a dummy CPU state and copy the next process state into that, and then call yield assembly with and of new state, which has a CPU state pointer. And when we call and assembly, we go to scheduler assembly. This is this symbol here, which just moves RSP into RDI, or moves RDI into RSP because this is Intel syntax. So the CPU state pointer that we passed it gets moved into the stack pointer. And then we jump here, which means that we pop everything off the stack and are good to go. TNT Master 58 says, I hate university. I feel you there. I'm taking a chemistry course and it sucks. You doing molecular orbitals? What are you doing? Molecular orbitals definitely suck. But yeah, exit doesn't return, so that's good. TNT Master says, yep, I'm doing that. I knew it. That's pretty much the only thing that sucks in chemistry. Everything else is pretty straightforward. The like electron energy level thing can be a bit confusing, but once you start to get a mental model, everything falls into place, right? But molecular orbitals are something that make me want to like bawl my eyes out because they suck. They do help a lot though once you can start to picture them, because you can start to see why we draw the things the way we do. You took chemistry? I didn't go to university and take chemistry. I've learned a lot of chemistry. Okay, well, I think that's it. I just racked my brain. I got nothing. Did you go to university? No, I dropped out of high school. I wasn't able to make it through sophomore year. So I'm a 9th grade graduate. That's sad. I appreciate that. Thank you. I don't think it's sad. What's sad about it? I don't like school. It didn't go well. It's not a good place for me. TNT Master says don't know. That's fair. It can just feel that way. Just sounds sad. Yeah, I basically just signed a million papers and said, I'm not going here anymore. School is just sometimes sad and depressing. Sometimes. School is the worst. It's it's not healthy at all. It's really bad for your mental and physical health. So it's really stressful and hard to deal with. And there's no one there to help you. You're just a kid and you got to deal with it. It's pretty sad. My case wasn't that sad. I just signed. I was like, I'm not going. I'm. I will end up dead if I keep going here. It's not worth it. I spend like 7 hours on homework every day. I'm so sorry. Hopefully it's fun. With homework, sometimes you can make it like into a thing and make it fun, or with molecular orbitals, I'm sure it's not that fun, though. I'm sure it's not that type of homework. Well, we're not going to get it working today. That's fine. Sometimes you fail. In my case, sometimes you fail before finishing 10th grade. Hurdy-hur. Grade 10, as you Canadians would say. Or at least you do over in Nova Scotia and in British Columbia. I'm not sure in the middle. You may have some different dialect of English. All right. You do say grade 10. Nice. That's one thing that they always laugh at me up there for. They would say, it's not 10th grade. It's grade 10. It's like, ah. That was like 5 years ago for me. We're very similar ages. I'm 20. I don't even remember. I've got a bad memory, and it doesn't make it easier that it was a stressful time and so many things happened at once. Where I'm moving and changing what I do every day, and also, oh, I don't see these people at all anymore, and it's really crazy. Anyway, hopefully nobody has stuck around this long. I feel bad for anybody watching the VOD. They're skipping through like, is he gonna code? The hell's going on? Anyway, I made an OS. I can't apparently free physical memory because everything's broken. And I don't know how to fix it. But I'll figure it out because I don't give up. You know, it is silly, but if you picture like the little engine that could. You just, you keep, there's a hill. We're just talking about university. That's a good thing you don't give up, but you did give up school. Yeah, in a way. I mean, it's not it's not like my home life was perfect. Everything's fine, and then I'm like, I'm not going to school. I'm just gonna stay home and play video games all day. That's not what it was like. It was more of like circumstances mean that this has to happen. Otherwise, bad things are gonna happen. You have your circumstances. Yeah, but I did give up. I could have kept going. It just, I didn't foresee it going well at all. Everyone has their own circumstances. That's right. And like, I don't think school is a bad thing, or it's like bad to go to school. I think it's great to get an education and go as far as you can and get a degree or do whatever, you know what I mean? Just know that it's not possible for everybody. Because like, even if I finished high school, I couldn't go to college financially. I'm in like the middle class as far as for some reason, they add up both your parents, even when you can only live with one at a time when they're split up. So I was in this bracket where it's like, oh, well, technically your household makes enough money where you don't qualify for free lunches, and you don't qualify for assistance, and you don't qualify for tuition help, and you don't qualify for anything. So you have to pay all that yourself. And then my parents are like, yeah, we don't have any money to pay like for that. You need assistance. You need a scholarship. And I was like, well, I can't play basketball. I'm a nerd. I'm lanky. I'm skinny. I'm not good at sports. I'm not coordinated. So it was like, you just can't. What's the solution? It's not like I can magically let me make $100,000 at 16 years old. Then I can go to college and get an education and make $100,000 at 24 years old. That way I can buy a Tesla, and at 36 years old I can spend $100,000. And it doesn't make any sense. It's just like an endless. I could win a Mr. Beast contest. Yeah, that'll help. That'll help for sure. But yeah, I don't view it as sad when you say that's sad, because they're just things that have happened, you know what I mean? Stoke, thank you so much for the follow. I appreciate it. I can't believe there are people sitting here listening to this, me talk about nothing. I appreciate it though. Hopefully you like the projects. Check out the Discord. There's all sorts of a community here for you. But yeah, I'll just win a Mr. Beast contest, make like 5K, and I'm good for life, because everyone knows 5,000 is easily, it's done. Just sell LensorOS as an SaaS and have people pay extra to be able to free physical memory. I would if I could. I would if I could. TNT says, we appreciate you talking to us. Thank you. It's hard sometimes. But to be honest, if I think about it, that is what I watch a lot in like the streamers I watch. When they're sitting there talking. When they're playing video games, I skip through it a lot because it's like they're just playing the video game. I don't know. I feel like any attempt that I give to try and put value or unvalue on what I'm doing when I'm streaming is just not going to work. Because like in the moment, there's no way for me to see whether it's a good thing or a bad thing. Because like in 2 weeks, it could blow up on YouTube because someone posted a short of this one clip that's 2.5 hours into a video. I've seen a streamer that had no viewers except me talk and talk. And it's hard to understand how you can just keep talking. Well, first of all, you need to make sure your voice doesn't give out, so you need to practice talking, as silly as that sounds. So whatever that means to you, you gotta, like, what's the point if no one's listening? Well, my OS, right? Who uses my OS? LensorOS, I made it. Suraid has helped a ton. What's it for? Who's using it? For what? Nobody's using LensorOS for anything, right? And they probably never will. No one's gonna go, what would be useful right now? LensorOS. Maybe in the future. Maybe. I doubt it. Why? Serenity OS has a future, right? It's like Serenity OS, you can see, that's gonna be something. Imagine LensorOS becomes the next Windows. That's fine. I mean, I would doubt it because it's free and open source, which is the opposite of what Windows wants. And also kind of the opposite of their business model of proprietariness. Lensor becomes a billionaire. Well, then, to me, that's sad. What am I going to do with $1 billion? Seriously, what am I gonna do? It's like, I have $1 billion. I'm not gonna do anything. I'm gonna sit here and code my OS still. It's not gonna change me. I'm still the same person. So it's like, okay, cool. I still just work on useless projects. Now I have $1 billion. Right? And we can do the same thing with like, I make an OS. When you become rich, people sugar up for money. Yeah, that does. I'm very good at seeing through that stuff. I've been in those positions before where you handle those things and people try and, the everyone's in a CYA mood, a cover your ass mentality, like anything to make sure the boss doesn't find out. And I hate that type of thing but it's all just because they need their money. But they only need their money to survive, and they only want to survive because they're alive. So that's not really their fault. But yeah, people definitely change when you get money. It's really sad. That's why I have none. I do think not that people treat you better, but I appreciate how people treat me when they think I have no money better. They look over me. They like look through me. It's like, you're not here. You're in a t-shirt with holes in it and some shitty jeans. You're not going to affect me ever. You know what I mean? They just have like a indescript feeling about me. I like that feeling. I don't want to show up in a suit and be like everyone's looking at him and go, oh, he's so professional and fancy. Look at that guy. I bet you he's rich. He looks awesome. I want to be him. It's like, can I just be the guy that nobody looks at? That'd be great for me. And then here's the confusing thing about my personality. That's what I think. But then I go and do things like stream. I could just do all this alone. There's no reason I need to stream, but I feel like streaming because I like talking to you guys, and it's awesome that I get to do this. I feel so privileged to be able to just spend time doing this, talking to you guys and working on projects that I like. But at the same time, So when you said like, what's the point if no one's listening? I think that there's more of a point when no one's listening. Because the words you choose are no longer being altered by anyone except yourself. So the words that you say all have to matter and make sense only to you. So then everything you say can just be for your own benefit, right? If no one's listening, you can feel lonely. Yeah, that's very true. You know why I don't feel lonely? And this is you're gonna say that's sad. You know why I don't feel lonely is because I listen to myself. When I have a thought, I don't just dismiss it. I listen to it and I think about it and I pretend basically, what if that's another person saying that to me and they're having this feeling and they're having this thing happen to them? What would I do for them? What do I think they should do? And then I do the opposite of that. And that usually goes pretty well. At least for me. TNT Master says that's probably the hardest part. I have an interesting personality. I don't really feel super lonely. I'm obviously not like immune. You know what I mean? I feel lonely. I feel like, oh, I haven't seen anybody in like 3 days. I gotta go to the gas station. You know what I mean? And then see a clerk and buy something and look in somebody's eyes and like, yep, we're both people. We're alive. This is good. Things are fine. But like, other than that, most of the time I just stay in my house. I don't leave. I don't do things. What's the point? I don't like going and hanging out with other people. It's never brought me any joy or brought me any benefit in my life. So it's hard for me to justify still doing it. If that makes sense. Like, I'm not the type of person I'm going to go to a party. I would host a party. I'd have a party and have people over. But it's going to be a very specific thing. You know what I mean? I'm not going to like go somewhere or do something. Social interactions can be hard. Yeah. I've found I've stopped caring. In middle school, obviously I was super self-conscious and I like didn't want to say the wrong thing or do the wrong thing. But really, it doesn't matter, is what you find out as you get older. Like, you can scream at someone and, like, you hate them and be so angry, right? And you know what they'll do to you? It depends on who it is. Most of people just go away and leave you alone and never talk to you again. And they go, man, that person's crazy. So from your perspective, you screamed at them and then you never see them again. You never talk to them, think about them, nothing happens. So it's like, maybe that wasn't the best choice. And there's definitely better and more mindful ways to go about scenarios. And you should never resort to violence unless you are defending yourself, right? But it's really, you have to stop caring. Like, what if they think I'm not the best person in the world? You're not the best person in the world, dude. You know what I mean? You're no one. You're some dude in their life. They just know you. You've been around each other. That's it. If they don't like you, all that happens is they say, I don't like them. You know, it's like nothing changes. Oh, I just bumped my mic. That was probably super loud. Nothing changes when people don't like you, or they all look at you and laugh and point. They're like, look, they have toothpaste on their shirt or something, right? It's like, it doesn't matter. Them laughing doesn't affect your life at all. Because having toothpaste on your shirt, everybody does it from time to time. You brush your teeth in the morning, you're in a hurry, you leave, you're going somewhere, you totally forget to look down, and then somebody goes, what's on your shirt? You look down and it's just giant bunch of toothpaste. TNT Master says, that's good. It doesn't matter what others think about you. Exactly. To an extent, if you want to, like, be kind, then there are still some things you have to think about. But the important thing is that you don't always have to be kind. TNT Master says, sadly, I have to leave now. Have a great dinner. That's all good. I'm sure people will appreciate not having to hear my dumb voice forever and ever. Mutter on. You have a good time, TNT Master. Thank you so much for tuning in. I like talking to you. Sir Aid, thank you so much for watching if you're still here. I appreciate you. Thanks for helping out, testing out QEMU on your system. Stuff like that helps so much to see if it's like you said, if it's just a Windows bug or if it's me or if it's some random cosmic bit flip from a cosmic ray, right? Who knows what it is? So stuff like that helps a lot. So it says no problem. TNT Master, have a great day. And your voice is not dumb. Aw, thanks. See, I don't even realize I say stuff like that. I probably said I have a dumb voice. It just happens. Thank you. I appreciate that. I'll try and think about that more often. But yeah, thank you, Sir Aid. I appreciate it. I am eternally grateful. I don't know what I would do in the OS if I was still using my terrible debug message overloads. Ugh, it's so awful. But yeah, hopefully we can get this physical memory thing working. If not, I guess it doesn't matter. We'll just allocate more RAM for QEMU and call it good. 128, right? Yeah, just make that 128 million. Just get me a bunch of memory, and we'll never worry about it. We're never gonna worry about it. Not once. But yeah, that's something we should probably work on. Hopefully I can fix it sometime. Thank you everybody so much for tuning in. I've got nothing left. I've had nothing left for the past 30 minutes. But I appreciate talking with you guys. It's so much fun. And yeah, let me know if you have any questions. Come to the Discord. There's tons of things. You can see awesome frame buffer corruption screenshots or get announcements every time I go live. You can ask to join the notifs group. Talk about anything, post memes, post songs. Yeah, do it all. We have a ton of fun. It's a great community. Stoke. Banger. I like it. Here. Yeah. Thank you everybody so much. We had 2 follows today, Just Chill and Stoke. Thank you so much. Be sure to join the Discord. Check it out. Check out the YouTube where all my VODs are uploaded. The Codeberg, where you can find all my open source, free and open source code for the OS, and my text editor. There's my GitHub where you have the compiler, the OS, the text editor, the bootloader, C Note, Ratty, Tree Sitter, and so much stuff. The Idle C game, Exploring D's, Korth. Go check it out. There's a ton of stuff to go look at, and I recommend it. Anyways, thanks all so much for tuning in. Stoke says, see you again. I'm a web dev but got bored. I'm getting interested in systems programming or some low-level stuff. That's awesome. Be sure to stick around. We work on compilers and assembly and C code and OSs, text editors. It's all low level. We don't do any high level stuff around here, so you'll have a fun old time if you want to learn more about that. But yeah, thanks all so much for watching. I've got nothing left. I'm going to say goodbye, let people get their last messages in, and then that's going to be it. Got some more awesome emotes. Beautiful stuff. But yeah, thanks all. I'll see you next time. Bye-bye. Bye.